Good day everyone. Today we are going to know what is a quadratic equation, and we will also learn how to identify if the given equation is a quadratic or not. And so, at the end of this video, the viewers or learners are expected to illustrate quadratic equation. This is a quadratic equation. A quadratic equation is a second-degree polynomial equation that can be expressed in standard form ax squared plus bx plus c equals 0, where a, b, and c are elements of real numbers and a should not be equal to 0. It is stated that a quadratic equation is a second-degree polynomial equation, meaning the highest exponent of the variable involved is 2. And the standard form of a quadratic equation must be written in this form, meaning your ax squared comes first, followed by bx, followed by c, then equated to 0. In other words, if the quadratic equation is not arranged in this manner, then it is not in standard form. Okay? So, and your quadratic equation can be called as complete quadratic equation if you have ax squared plus bx plus c equals 0, meaning the term ax squared and bx and c must be present to be considered that as quadratic or complete quadratic equation. So your ax squared is called as quadratic term, your bx is called a linear term, and c is the constant term, while the a in your ax squared is called the quadratic coefficient, and your b in your linear term is called the linear coefficient. Again, to be considered that as a complete quadratic equation, the quadratic term, the linear term, and the constant term must be present. Otherwise, we call that as incomplete quadratic equation. When we say incomplete quadratic equation, if the linear term or constant term are missing, or both linear and constant term are missing. Okay? Let's have a short exercises to verify if we really understand the concept of quadratic equation. So, which of the following are quadratic equation? So, let us start with x squared minus 2x plus 1. So, is this a quadratic equation? The answer is no. This is not a quadratic equation. Even though the highest exponent is 2, but it has no equal sign. Therefore, it is not a quadratic equation. We can only call this one as quadratic expression. Okay? The next given is x plus 2 times x minus 7 equals 0. Is it a quadratic equation or not? Okay, this is a quadratic equation. So, to verify if it is really a quadratic equation, we have to expand the product of x plus 2 and x minus 7. So, if we expand, we'll come up with x squared minus 5x minus 14 equals 0. Okay? The next one is 3x squared minus 4x equals 0. Is it a quadratic equation or not? So, it is a quadratic equation. Okay? How about x cubed minus 4x plus 3x minus 5 equals 0? It is not a quadratic equation because the highest exponent is 3. And we call this equation as a cubic equation. The next one is x times the quantity of 2x minus 4 equals 0. Is it a quadratic equation or not? Okay, so that is a quadratic equation. Because if we are going to expand the product of x and 2x minus 4, we'll come up with 2x squared minus 4x equals 0. So that's a quadratic equation. Next is 5 plus 2x minus x squared equals 0. Is it a quadratic equation or not? It is a quadratic equation. we can only arrange that to form in standard form as negative x squared plus 2x plus 5 equals 0. The highest exponent is 2 and it has an equal sign. Okay, last one is x squared times 5 minus x equals 0. Is it a quadratic equation? The answer is no. It's not a quadratic equation because if we expand the product of x squared and 5 minus x, it becomes 5x squared minus x cubed equals 0. So the highest exponent is 3. And therefore, this is not a quadratic equation. This is a cubic equation. That is how to identify if the given equation is a quadratic equation or not. So, okay, let us have another exercises that has something to do with the concept of quadratic equation. Okay, so write the following quadratic equation in standard form and identify the values of a, b, and c. Okay, before we answer the given question, let us first recall the standard form of quadratic equation. The standard form quadratic equation is written in this particular manner: ax squared plus bx plus c equals 0. Okay, the quadratic term will comes first, followed by the linear term, followed by the constant, and it is equated to 0. So if we will answer the first one, this one, we simply rearrange the terms. So negative x squared, the negative x squared comes first, followed by 5x, the linear term, and followed by the constant 6, then equated to 0. So that's now the standard form. What's the value of a? That's negative 1. The value of b, which is the coefficient of x or the linear term, 5, and the constant is positive 6. Okay, so the second is x squared equals 2x. To write that in standard form, we simply transpose this 2x to the left side. So it will become now x squared. If you transpose this one, 2x, it will become now negative 2x equals 0. Then we can now identify the value of a. The value of a is 1. Even though there is no number beside x squared, it is understood that the coefficient is 1. Then your linear coefficient is equal to negative 2. And your constant is 0 because it's the missing term in the given. Okay? Then next is the product of x times x plus 5 equals 6. To write this in standard form, we have to expand first the product of x and quantity x plus 5. So we multiply x times x, so we have x squared. Then we have x times positive 5. We have positive 5x. Then we'll transpose 6 to the right side, to the left side. It will become negative 6 equals 0. And what is the value of a? The value of a is 1. The value of b is 5. And the value of c is negative 6. Okay? So next is x minus 7 all over x, then equals x plus 1. First, we have to clear the equation. When we say clear the equation, we have to eliminate the denominator by multiplying it by x, both sides of the equation. So if you multiply both sides by x, so this will be cancelled. So you have now x minus 7, and this one, x times x, is x squared, and you have x times 1, you have x. Then we arrange or transpose. So we have now, we transpose this one, it will become negative x squared minus x plus x minus 7 equals 0. So we change the sign of x squared. This one, it becomes negative x squared. And this x also we transpose, so we change the sign. Since x here is already in the left side, the sign will remain unchanged. Same with negative 7. So you still have their negative 7 equated to 0. And we will combine similar term. So you have now negative x squared. Then negative x plus x. This will be cancelled. So you have 0. So you only have now negative 7 equals 0. So this is now an incomplete quadratic equation wherein the linear term is missing. So what's the value of A? So the value of A is negative 1. What's the value of B? Since it is the linear term is missing, the value of B is 0. And what is the value of C? And that is negative 7. So that is how to write the value, the given quadratic equation in standard form, and how to find the value of A, B, and C. So before we can identify the values of A, B, and C, we need to write it first in standard form. Okay? Okay, let us have a final exercises on how to illustrate quadratic equation. Write an integral quadratic equation in standard form given the values of A, B, and C. So remember that our standard form of quadratic equation is ax squared plus bx plus c equals 0. So this is our pattern on how to write it in standard form. So it is given that the value of A is positive 3, the value of B is negative 7, and the value of C is equal to 4. So we simply replace this A by the given value 3, and your B will be replaced by negative 7, that's the value of B, and your C will be replaced by positive 4. So the result is 3x squared minus 7x plus 4 equals 0. Okay? That's as simple as that. Okay, the second one, the given is A plus B equals 10, meaning the sum of A and B is 10. Then C minus B equals 2, and the value of A is equal to positive 3. So we have a direct value of A, but we don't have direct value for values for A, for B and C. So what we are going to do now is to get the value of B by solving the equation A plus B equals 10. Since we already have direct value for A, which is positive 3, we replace this A by 3 plus B equals 10. Then we solve for B. So we simply transpose this positive 3 to the right side. It will become negative 3. And B now is equal to positive 7. So our B is positive 7. And to find the value of C, we'll use this equation. So C, since we already have value for B, 7, replace B by 7 equals 2. Solve for C, we simply transpose negative 7 to the right side. So you have 2 plus 7. So our C now is 9. Okay? So the value of A is positive 3, the value of B is 7, and the value of C is 9. So we can now substitute these values to our pattern or model ax squared plus bx plus c equals 0, and it will become 3x squared plus 7x plus 9 equals 0. Okay? Then next, the last one, A is 1/2, B equals negative 5, and C is equal to positive 3. We simply directly substitute the value of A to the model, the value of b, and the value of c. So we have now 1/2 x squared plus 5x plus 3 equals 0. But remember, this is not the final answer, because in the direction, it is stated that we are going to write an integral quadratic equation. When you say integral quadratic equation, all the coefficients must be integers. 1/2 is not an integer. So we are going to simplify that. How? So we simply remove 1/2. How to remove 1/2? So we'll think a number that if we multiply to 1/2, the answer is 1. So gagawin natin, multiply natin both sides by positive 2. Positive 2. So 2 times 1, 2 divided by 2, 1 times x squared, so you have x squared. Then next is 2 times positive 5x, so you have 10x. Then 2 times positive 3, you have positive 6, equals 0 times 2 is 0. Meaning our answer now is x squared plus 10x plus 6 equals 0. So that's the final answer. Again, the final answer is x squared plus 10x plus 6 equals 0. So that is how we write a quadratic equation in integral quadratic equation in standard. Okay, that's all for today. Until next time.